Hello guys, so I hope you are doing well. So in this video we are going to solve another problem, that is find the largest sum contiguous subarray. So let's move on the problem and see what are the other information related to this problem. So let's move on. So here is the problem statement, and this problem says that given an integer ARR of n integers, find the contiguous subarray which has the maximum sum and return its sum. So let's understand this by an example. So initially current sum will be 0 and max sum will be minimum value of the integer. So let's traverse from the 0th element to the n minus 1 element of the array. So for 1 current sum will be 0 plus 1, so that is 1, and maximum will be updated by maximum value of the maximum and the current sum, so it will become 1. For the next element 2, we maintain our current sum by adding the highest element of the array and the previous sum. So the current sum will be 1 plus 2, that is 3, and let maximum sum will be maximum from both, so maximum will be updated by 3, and current sum is not less than 0, so will remain continue this process. And for minus 2, so and for second element we add 3 in the previous sum, so our current sum will be 6, and max sum will be updated by 6 because current sum is greater than maximum. And for minus 2, current sum will be 6 minus 2, that is 4. Here current sum will be minus 4, that is less than max sum, so max sum will remain unchanged. So we and current sum is not less than 0, so we continue our process. So for the 5 we add in the current sum 5, so the output will be 4 plus 5, that is 9, and here current sum is 6 and current sum is 9 and max sum is 6, so the max sum will be 9, and 9 is the largest sum from the contiguous subarrays of any given array. So let's understand this by an this example. So initially current sum will be 0 and max sum will be the minimum value of the integer. So for minus 1, current sum will be 0 minus 1, that is minus 1, and max sum will be updated by minus 1 because minus 1 is greater than integer's minimum value. So for minus 2, we add minus 2 in minus 1, it will become minus 3, and maximum value from minus 3 and minus 1 is minus 1, so maximum sum will be minus 1, and current sum is not equal less than 0, so it will continue this process. So for minus 4, we add minus 4 in minus 3, so it will become minus 7, and the current sum is not less than 0, so it will continue this process, and max sum will be maximum from current sum and max sum, so it will remain minus 1, so the output is minus 1. It is the largest sum from the contiguous subarray of given array minus 1, minus 2, minus 3, and minus 4. So let's understand this by a new example. So for the given array 1, 2, minus 3, minus 2, 5. So let's initially current sum will be 0 and max sum will be minimum value of the integer. So for 1, current sum will be updated by 0 plus 1, that is equal to 1, and current sum is 1 and max sum is minimum value of the integer, so it will updated by maximum from the both, so it will become 1. For 2, current sum will be previous sum plus new element, that is 1 plus 2, it will become 3. So maximum sum will be updated by 3. For minus 3, current sum will be 3 plus minus 3, that is minus 3, and it equal to 0, and max sum is remain unchanged because current sum is less than max sum. So for minus 2, we add a minus 2 in previous sum, that is 0 minus 2, that is become minus 2. So here if we can see that current sum is less than 0. If current sum is less than 0, so it will affect our next sum. So if we add a current sum in a next term, so it will reduce the next term. So if we add minus 2 plus 5, it will become 3. But here 5 can be a contiguous subarray of element 1. So if our element current sum is less than 0, it will updated by 0. So if it is 0, so max sum is 3 and current sum is 0, it max sum will remain 3. For 5, we add 5 in current sum, it will become 5 instead of 3. So a max sum will be updated by 5. So the max sum of the contiguous subarray of 1 to minus 3 minus 2 5 is become 5. So here is the condition can match if current sum is less than 0. Current sum will be updated by 0 because it will be going to affect our next term sum. So here is the code of this program. So initially current sum will be 0 and max sum will be minimum value of the long. So in a loop, we traverse from 0th element to the last element of the array, and current sum will be updated by adding the ith element in the current sum, and max sum will be updated by maximum value from current sum and maximum sum. And here if current sum is less than 0, current sum will be updated by 0, and after the loop we are going to return max sum, that will store the maximum sum from the contiguous subarray of given array. So let's submit this program. This solution passes all the test cases, so it is an effective approach because the time complexity of this approach is bigger often. Here we traverse the array from 0 to n at least once. So the time complexity of this program is going to bigger often. So if you are saying this content is helpful to you, so let's like, comment and share, and don't forget to subscribe our channel. Thanks for watching.